Chapter 5. Why is the universe fine-tuned for life? Ever since the creation of the world, his invisible nature, namely, his eternal power and deity, has been clearly perceived in the things that have been made. Romans 1:20. The ancient Greek philosophers were struck with the order that pervades the cosmos. The stars and the planets in their constant revolution across the night sky were especially awesome to the ancients. Plato's Academy lavished extensive time and thought on the study of astronomy because, Plato believed, it was the science that would awaken man to his divine destiny. According to Plato, there are two things that lead man to believe in God: the argument from the existence of the soul, and the argument from the order of the motion of the stars, and of all things under the dominion of the mind which ordered the universe. Plato employed these arguments to refute atheism, and concluded that there must be a best soul, who is the maker and father of all, the king, who ordered the primordial chaos into the rational cosmos that we observe today. Plato's Academy. Around 387 BC, the Greek philosopher Plato purchased a house in a park known as Academeca, just outside Athens, and there he opened a school that flourished for an astonishing 900 years, until it was shut down by the Byzantine emperor in AD 529. Plato's goal was the search for truth by means of rational inquiry. The Academy drew both senior thinkers and younger students, who explored together by means of dialogue profound questions concerning the ultimate nature of reality, the good, the soul, logic, mathematics, and astronomy, as well as politics and society. Among the pupils who came to study at the Academy was an 18-year-old named Aristotle, who remained there until Plato's death. The influence of the Academy upon Western thought and history, via those who passed through its gates, is incalculable. An even more magnificent statement of divine design is to be found in a fragment from a lost work of Aristotle entitled On Philosophy. Aristotle, too, was filled with wonder at the majestic sweep of the glittering host across the night sky of ancient Greece. Anyone who has personally studied the heavens must lend a sympathetic ear to these men of antiquity, who gazed up into the night sky, undimmed by pollution and the glare of city lights, and watched the slow but irresistible turn of the cosmos, replete with its planets, stars, and familiar constellations, across their view, and wondered, what is the cause of all this? Aristotle concluded that the cause was divine intelligence. He imagined the impact that the sight of the world would have upon a race of men who have lived underground and never beheld the sky. When thus they would suddenly gain sight of the earth, seas, and the sky, when they should come to know the grandeur of the clouds and the might of the winds, when they should behold the sun and should learn its grandeur and beauty, as well as its power to cause the day by shedding light over the sky, and again when the night had darkened the lands, and they should behold the whole of the sky spangled and adorned with stars, and when they should see the changing lights of the moon as it waxes and wanes, and the risings and settings of all these celestial bodies, their courses fixed and changeless throughout all eternity, when they should behold all these things, most certainly they would have judged both that there exist gods, and that all these marvelous works are the handiwork of the gods. Talk about it. Go outside at night and look up at the sky. How is what you see different from what Aristotle might have seen? How do you think this difference affects the way people today think and feel about the stars and planets? In his Metaphysics, Aristotle went on to argue that there must be a first uncaused cause, which is God, a living, intelligent, immaterial, eternal, and most good being who is the source of order in the cosmos. Reading the works of these ancient philosophers, one cannot help but think of Paul's words in his letter to the church in Rome. Ever since the creation of the world, his invisible nature, namely his eternal power and deity, has been clearly perceived in the things that have been made. Romans 1:20. From earliest times, men wholly ignorant of the Bible have concluded on the basis of the design in the universe that God must exist. The rebirth of design. Today, many astronomers, as a result of recent discoveries, are coming to a similar conclusion. Scientists used to think that whatever the very early universe might have been like, given sufficient time and some luck, intelligent life forms like ourselves would eventually evolve somewhere. As a result of discoveries over the last 40 years or so, we now know that that assumption was wrong. In fact, quite the opposite is true. Astronomers have been stunned by the discovery of how complex and delicate a balance of initial conditions must be present in the Big Bang itself if the universe is to permit the existence of intelligent life anywhere at all in the cosmos. This delicate balance of initial conditions has come to be known as the fine-tuning of the universe for life. We've come to discover that the universe is fine-tuned for the existence of intelligent life with a complexity and delicacy that literally defy human comprehension. Two kinds of fine-tuning. There are two kinds of fine-tuning. The first involves the constants of nature, and the second involves certain arbitrary physical quantities. Nature's constants. First, the constants of nature. What is a constant? When the laws of nature are expressed as mathematical equations, you find appearing in them certain symbols that stand for unchanging quantities, like the force of gravity, the electromagnetic force, and the subatomic weak force. These unchanging quantities are called constants. The laws of nature do not determine the value of these constants. There could be universes governed by the same laws of nature, even though these constants had very different values. So the actual values of the various constants are not determined by nature's laws. Depending on the values of those constants, universes governed by the same laws of nature will look very different. Constants of nature. When the laws of nature are expressed as mathematical equations, certain constants feature prominently in them. Consider, for example, Newton's famous law of gravity. It states F equals gm1 m2 over r2. According to this equation, the force of gravity, symbolized by F, is equal to the value of the gravitational constant g multiplied by the masses of the two bodies that are being attracted to each other divided by the distance between them squared. The masses and the distance may vary depending on what objects you're talking about, but the value of g is constant. Arbitrary quantities. In addition to the constants, there are certain arbitrary quantities that are just put in as initial conditions on which the laws of nature operate. Because these quantities are arbitrary, they're also not determined by the laws of nature. An example would be the amount of thermodynamic disorder, or entropy, in the early universe. It's just given in the Big Bang as an initial condition, and the laws of nature then take over and determine how the universe will develop from there. If the initial quantities had been different, then the laws would predict that a quite different universe would result. Definition of fine-tuning. Now, what scientists have been surprised to discover is that these constants and quantities must fall into an extraordinarily narrow range of values for the universe to be life-permitting. This is what is meant by the fine-tuning of the universe for life. Talk about it. Imagine a universe in which the gravitational constant, g, was considerably stronger than in our universe. Do you think there could be galaxies in that universe? Why? Examples of fine-tuning. Fine-tuning, in this neutral sense, is uncontroversial and well established. Physics abounds with examples of fine-tuning. Before I share a few, let me give you some numbers to give you a feel for the delicacy of the fine-tuning. The number of seconds in the entire history of the universe is around 10 to the 17th power. That's 1 followed by 17 zeros. The number of subatomic particles in the entire known universe is said to be around 10 to the 80th power, 1 followed by 80 zeros. Such numbers are so huge they're simply incomprehensible. Now, with those numbers in mind, consider the following examples of fine-tuning. The so-called weak force, one of the four fundamental forces of nature, which operates inside the nucleus of an atom, is so finely tuned that an alteration in its value by even 1 part out of 10 to the 100th power would have prevented a life-permitting universe. Similarly, a change in the value of the so-called cosmological constant, which drives the acceleration of the universe's expansion, by as little as 1 part in 10 to the 120th power, would have rendered the universe life-prohibiting. A key distinction. The term fine-tuned does not mean designed. The expression is a neutral term that doesn't say anything about how the fine-tuning is best explained. Fine-tuning just means that the range of life-permitting values for the constants and quantities is extremely narrow. If the value of even one of these constants or quantities were to be altered by a hair's breadth, the delicate balance required for the existence of life would be upset and the universe would be life-prohibiting instead. Remember the low entropy state in which the universe began? We talked about it in Chapter 4 under the law of thermodynamics. Roger Penrose of Oxford University has calculated that the odds of that low entropy state's existing by chance alone is on the order of 1 chance out of 10 to the 10th power times the 123rd power, a number that is so inconceivable that to call it astronomical would be a wild understatement. The fine-tuning here is beyond comprehension. Having an accuracy of even 1 part of 10 to the 60th power is like firing a bullet toward the other side of the observable universe 20 billion light-years away and nailing a 1-inch target. The examples of fine-tuning are so many and so various that they aren't likely to disappear with the advance of science. Like it or not, fine-tuning is just a fact of life that is scientifically well established. Talk about it. How does it affect you to know that the universe is so precisely fine-tuned? A possible objection and its answer. Now some of you might be thinking, but if the constants and quantities had different values, then maybe different forms of life might have evolved. But that underestimates the truly disastrous consequences of a change in the values of these constants and quantities. When scientists say a universe is life-permitting, they're not talking about just present forms of life. By life, scientists just mean the property of organisms to take in food, extract energy from it, grow, adapt to their environment, and reproduce. Anything that can fulfill those functions counts as life, whatever form it might take. And in order for life, so defined, to exist, the constants and quantities of the universe have to be unbelievably fine-tuned. In the absence of fine-tuning, not even matter, not even chemistry would exist, much less planets where life might evolve. A fly on the wall. The philosopher John Leslie gives the following illustration to show why we needn't be concerned with universes governed by differing laws of nature. Imagine a solitary fly resting on a large blank area of the wall. A single shot is fired, and the bullet strikes the fly. Now, even if the rest of the wall outside the blank area is covered with flies, so that a randomly fired bullet would probably hit one, nevertheless it remains highly improbable that a single randomly fired bullet would strike the solitary fly within the large blank area. A life-permitting universe is like that solitary fly on the wall. When we consider universes governed by our laws of nature, almost all of them are life-prohibiting. So the odds that a universe selected randomly out of this lot would be life-permitting are practically nil. Another objection and its answer. Sometimes people will object, but maybe in a universe governed by different laws of nature, such as disastrous consequences might not result. But this objection betrays a misunderstanding of the argument. We're not concerned with universes governed by different laws of nature. We have no idea what such universes might be like. Rather, we're concerned solely with universes governed by the same laws of nature, but with different values of the constants and arbitrary quantities. Because the laws are the same, we can determine what would happen if the constants and quantities were to be altered. And the results turn out to be disastrous. Among universes governed by our laws of nature, there is almost no chance that a randomly chosen universe would be life-permitting. An argument for design. The question we face then is this: what is the best explanation of the cosmic fine-tuning?